Okay, so we're moving on to day 3, having looked at day 1 and 2, transformations, compositions, and inverses. This question says, sketch a graph of f of x equals 3 over x minus 6 plus 2, labeling the asymptotes and 2 points. And then it says, give the transformation function that maps g of x equals 1 over x onto f of x, and give the domain and range of f of x. I think actually finding the transformation function first might be a good decision, and then we can sketch. So f of x could also be written as f of x equals 3 times 1 over x minus 6 plus 2, because 3 over x minus 6 is the same thing as 3 times 1 over x minus 6. So here we can see that outside of the function we're scaling by 3 and adding 2, so moving up 2 and stretching by 3. And inside the function we're subtracting 6 from x, which should move it to the right. That is for the parent function 1 over x. So I'm going to say that t of x comma y should send these points to x plus 6. Remember, we're thinking of solving for x, so that means add 6. And then 3 times y plus 2. So knowing what I know about the parent function, which looks like this, 1 over x, there's a point here at 1, 1, and a point here at negative 1, negative 1. So those would be good points for me to move. Because it's moved to the right 6 and up 2, that should give me my asymptote. So here's an asymptote at 6, and here's an asymptote at 2. Now I'm just going to plug in 1, 1 and negative 1, negative 1. Those are points on my parent function. So if I plug those into my transformation function, I should get 7, 5. So 7, 5 is right there. And then I'm going to plug in negative 1, negative 1. I should get 5, negative 1. So 5, negative 1 is right here. So normally when I plug points on either side of the asymptote, I should have gotten 1 and 3. They should have been right here, but because they're multiplied by 3, it's stretching them up by 3. And from there, I can just give a basic sketch, which is going to look something like this. Domain and range, well, that deals with the asymptote. So the domain, the value of x that you cannot plug in is 6. Right? Because 6 minus 6 is 0, we'd be dividing by 0, that's undefined. And the range should simply be y does not equal 2, because otherwise it equals everything else, it just doesn't cross 2. So that would be a sketch of 3 over x minus 6 plus 2. Moving on to number 6, we've got some functions and we're asked to combine them. Write your answers exactly. So this says g of f of h of 1. So I'm going to find h of 1 first. If I plug 1 in here, I get 2 minus 4, which is negative 2. So this should be g of f of negative 2. Now I'm going to find f of negative 2. Well, negative 2 plus 5 is 3. 3 squared is 9. 9 times 2 is 18. So that should be g of 18. And if I plug 18 in here, I get 18 minus 8, which is 10. That should be square root 10 plus 1. No real way to simplify that, so I'm done. That's an exact answer. Now g inverse of 7. Okay, so for g, this is a y value, and for g inverse, it's an x value because they swap. So I'm going to let 7 equal g of x and solve for the x value because my x and y values swap for inverse functions. Subtracting 1, I get 6 equals square root x minus 8. If I square both sides, I get 36 equals x minus 8. Adding 8, I should get 44 equals x. Now let me just double check. If I plug 44 in here, I get 44 minus 8. That's 36. Square root 36 is 6 plus 1 is 7. So a point on g of x is 44 comma 7, which means a point on g inverse is 7 comma 44, so that means g inverse of 7 needs to equal 44 because we've swapped the x and y values. H of h inverse of 0, they undo each other, that's 0. G inverse of x, find it in terms of x. Well, I'm going to note that g of x is y equals square root x minus 8 plus 1. So I will swap and solve. X equals square root y minus 8 plus 1. Subtract 1. X minus 1 equals the square root of y minus 8. Square both sides. I get x minus 1 squared equals y minus 8. So x minus 1 squared plus 8 equals y. Now, you'll notice that this has been moved to the right 8 and up 1. So this has been moved to the right 1 and up 8. It's the inverse. This has a domain and range, g, of simply x is greater than or equal to 8 and y is greater than or equal to 1. So I have to restrict this to simply x is greater than or equal to 1. Otherwise, to match the range of my inverse. Otherwise, I'll get a piece of this that actually doesn't match. So that's what I end up with right there. What is the domain of G composed of F? Well, first of all, I need to look at the domain of F and note that the domain of F is all reals. I can plug anything in there. Next, I need to look at G and note that whatever I plug into G needs to be greater than or equal to 8. Otherwise, I'm taking the square root of a negative. So that means because I'm plugging F in instead of X, I need F to be greater than or equal to 8. So that means I need 2 times x plus 5 squared to be greater than or equal to 8, right? Because that's F, which means I need x plus 5 squared to be greater than or equal to 4. Now I gotta be careful when I take a square root, right? Because I get the positive and the negative. So basically what this tells me is I need this thing to be greater than or equal to 4. That means that x plus 5 needs to be greater than or equal to 4, or x plus 5 needs to be less than or equal to negative 4. Right? I got to be really cautious here because I took a square root, and when you take a square root in an equation, you need to use an absolute value. So this is really coming from the absolute value of x plus 5 needs to be greater than or equal to 4. And from there, I need to do the positive and the negative and say less than or equal to negative 4 and greater than or equal to 4. This is basically saying I need this distance to be bigger than 4. So I either need it to be bigger than 4 or less than negative 4. For there, I get x, it needs to be greater than or equal to negative 1, or x needs to be less than or equal to negative 9. So I could write that perhaps as negative infinity to negative 9, union negative 1 to infinity. So all of these values, if I plug them into F, I'll get values that are bigger than 8. Thinking about the graph of F, I'll just do that, say, down here. The graph of F, well, it has a 0 at negative 5 with multiplicity 2. It has a y-intercept of something very big. It looks like this, you know, and here's 8. And basically what we're saying is from here on, it's above 8. And from here back, it's above 8. This just happens to be negative infinity to negative 9. And this just happens to be negative 1 to infinity. Tricky question. For F, it says, what are the transformations that send the parent functions of each of f, g, h onto f, g, and h? So F, all right, well, let's remind ourselves what F was. F was 2 times x plus 5 squared. The parent function is x squared. So this should be then, let's see here. Well, we're sending xy to x minus 5 and 2y. For g of x, the parent function would be root x, and we are basically saying we're going to send those points on the parent function to x plus 8 and y plus 1. Just a simple translation. And for h of x was 2 over x minus 4, which means the parent function is 1 over x. We're taking those values and we are sending them to, let's see here, 2 times 1 over x. We're just sending x to x, but we're sending y to 2y minus 4. So those would be the transformations that map f, g, and h, their parent functions, onto themselves. Okay, I think we've got a few more problems here related to transformations. So here, this is giving us some points. It says the function f of x is an even function excuse me, that satisfies the given conditions. F of 0 equals 3. F of 1 equals -1. F of -2 equals 0. And f of -3 equals 4. Okay, if it's even, we know that f of x equals f of -x, aka it's symmetric across the y-axis. So all these points have to be reflected across the y-axis. This point needs to come over here. This point doesn't move. This point needs to come over here as well, and this point needs to come over here as well. It says make a sketch of the known points of f of x with domain -3 to 3. That would be the sketch of the known points of f of x. I graphed all the ones they gave me, and then I simply reflected them across the y-axis because it is even. Looking at number 8, says the equation C equals 5/9 times F minus 32 is useful in converting the temperature from degrees Fahrenheit to degrees Celsius. What equation would be useful in converting the temperature from degrees Celsius to degrees Fahrenheit? Well, the inverse, of course. So how do you find the inverse? Well, you swap and solve. So C equals 5/9 times F minus 32. We don't really want to swap, because if we swap, we're going to get confused about which is Celsius and which is Fahrenheit. So we'll simply solve this for Fahrenheit. Multiply by 9/5. So 9/5 C equals F minus 32. Add 32. Fahrenheit is equal to 9/5 times the degrees Celsius plus 32. That's the inverse function, but we'll write it with F and C. Finally, number 9. Oh, actually, maybe there's one more after this. No, I don't think so. This is the real meat and potatoes of the section. It says, consider the following four functions, name their parent functions, write the transformation function that maps onto each, describe the transformations in words, sketch their graphs, find their domains and ranges. Okay? Parent. Root x. Transformation function. Well, it takes x and y and it sends it to, well, what's happening to x? Well, it'd be good to probably factor this. Remember that this means that y equals the square root of 2 times x plus 3 plus 2. That's probably how I would rewrite that. It's a little bit easier to understand. If I were solving this for x, I would divide by 2 and then subtract 3. That means 1/2 x minus 3. It's a horizontal scale by 1/2 and then move to the left 3. I'm simply adding 2 to the function. That should be y plus 2. I'm going to describe this again. I am scaling by 1/2 horizontally. Then I am moving to the left 3. Here I am moving the function up 2. Okay, you'll notice that the domain and range of this parent function is x is greater than or equal to 0 and y is greater than or equal to 0. So the domain and range of the new function should be 1/2 times 0 minus 3, or x is greater than or equal to -3, and y is greater than or equal to 2. I'm actually plugging these into my transformation function to get these values. So that's cool. Y equals -4 e to the x. Oh my goodness, we didn't actually even sketch it. So, oh boy. All right, well, we need an axis. Let's say that this is our axis right here, and let's say that this is our axis right here. So we'll let that be our axis. So this one, plug in a couple points. On the parent function, we have 0, 0. So on this function, we have -3, 2. -1, 2, 3, 2 is right there. On the parent function, we would have 1, 1. So now we have 1/2 minus 3, which is -2.5, 3. So negative 1, 2.53 is right there. The y-intercept of this, if I plug in 0, would be root 6 plus 2. Root 6 is bigger than 2, so that's going to be like 4 point something, I think. And that's probably enough points to give me a good thing. You'll see here that because this is negative 3, you can see my domain of x is greater than or equal to negative 3, and my range of y is greater than or equal to 2. Okay, how about b? Parent function. Oh, I'll just call it e to the x. Which, by the way, has domain. X is an element of the reals, and y is greater than 0. What have we done to it? Well, everything is outside. Nothing has been done to x. So t of x comma y simply sends these points to x comma negative 4y plus 2. So nothing has been done horizontally, but that's a vertical scale by 4, a vertical reflection, and a vertical shift. I've shifted it up 2. So I'm going to make some axes here. That's my x-axis. And here's my y-axis. Okay. Let's see here. If I plug in, say, 0, 1, because that's on the parent function, I will get 0, negative 2. So 0, negative 2, that is right here. If I plug in 1e, I will get 1 and negative 4e plus 2. That's like way, way, way down here somewhere. If I plug in negative 1, 1 over e, I would get negative 1 and something here. I don't know exactly. What I do know is that my asymptote has to be at 2 now. And so I should be able to get at least some general sketch, very steep like that, of my new function. It's been reflected down, right? That vertical reflection with the negative. It's much steeper because of the 4. And the most important thing is probably that we've got that asymptote there. So now we can see that my domain is still x as an element of the reals, but y is less than 2. Okay, I think we've got 2 more questions to look at, and then we're going to call it good on day 3. Negative 1/2 x squared plus 3. Well, the parent is x squared. The transformation is going to be t of x comma y sends these points to, well, 2x, because I'm trying to solve for x, and then negative y plus 3. So I've got a horizontal scale by 2, vertical reflection, and I've moved it up 3. So thinking about the graph of x squared, remember x squared passes through 0, 0. So this one passes through 0, 3. 1, 2, 3. The graph of x squared passes through 1, 1. So this one passes through 2, 2. 2, 2. And it's got to be symmetric over here because I haven't really moved it left or right. So I get that point right there. And from there, I should be able to get a decent sketch of my function. And of course, my domain is all real numbers, and my range is y is less than or equal to 3. For the parent function, it's greater than or equal to 0, but I've reflected it, so it should be y is less than or equal to 3. Log base 2 of x minus 4. Parent, log base 2 of x. Transformation, I've simply taken t of x comma y, and I've moved these points of the parent to x plus 4, moved to the right 4, and y has not changed. So normally the graph of log base 2 of x has an asymptote at 0, but this one's moved 1, 2, 3, 4 over here. If I plug in the point that's on the parent, which would be, say, 2, 1, if I plug in 2, I get 1. I'm going to get 6, 1. That's right here. If I plug in the point 1, 0, I'm going to get 5, 0. That's right here, and you can kind of see from there that it's going to do this. I've moved it over so my domain is now x is greater than 4. And that makes sure that what I'm plugging in here is positive, and my range is still y is an element of the real numbers. And that takes care of day 3.